G'day guys, Mr. Bennett here. Now today we're going to be looking at radioactive decay or half-lives, and simply half-life is the time taken for either the number of counts per minute or the mass to get to half of its original amount. Okay, now there's a nice little formula here that will actually help us to be able to do any calculation, and that is N, which is the amount of material or the number of counts, is equal to the original. So N is the initial mass or the initial counts, and that's a half, and then N is the number of half-lives that we've actually got there. So that is probably a formula that you will need to sort of remember, I think. But the concept of a half-life is that it's the time taken to get to half its original amount. So as you can see in the diagram, okay, obviously if you had 100 things there, to get to 50, that's what we call one half-life. Then to get to 25 would be two half-lives, and 12 and a half would be three half-lives, and then to get to the next half-life that would be 6.25, and so on. Now obviously they don't normally come in nice round values like that, of course. So if we had started with 200 grams of something, or 200 counts, then 100 would be one half-life, then 50 would be two half-lives, 25 would be three half-lives, and so on. Get the concept? So it's just very important. So if we said that in this particular case we started with 128 grams of carbon-14, the half-life of carbon-14 is 200 minutes, how long would it take to decay to 8 grams? Alright, so what we have to do is work out the number of half-lives. So obviously we're putting in the value where it's actually going to get to, so 8 is what it's decaying to. We start with originally 128 grams, and we have a half there. Now there's a number of ways of solving it using some mathematics. Here's one way, just conceptually: 128, 64, 32, 16, 8. So that is how many half-lives? Well, that's 4 half-lives, if we think about it that way. If we use our formula, we'd do 8 divided by 128, which is going to give us 1 over 16. Okay, and then we're looking for a power of 2. We want to make that the same. So therefore, we can see that these are equating. If we have the same base number, we can equate. So if we've got 4 half-lives, then that equates to being 4 lots of 200, which would be 800 minutes of take. Alright, so if we did the same sort of thing, if we started with 64 getting down to 1, that would be in fact equal to 6 half-lives. Okay, looking at that scenario. So you can either do it this way here, that, looking at multiples of. You can look at how many half-lives it is, or you can use the formula as I've shown you here. Right, the main thing is it's not going to be, might be in the exam, but it's a conceptual thing more than anything else. But I would certainly know the formula that I just showed you up on the top there, which was, if we just write it again for you. Okay, so it's N, so if we're looking at formula, it's N is equal to N0, then it's the number of half-lives to the half to the number of our half-lives. Okay, so that's a formula you need to know for this stuff here, but certainly the concept you need to know, that concept about half-lives.